Hi everybody. So a little while ago, a friend of mine asked me if it was possible to build a device that would log the household power consumption. And it just happened that this was something that I had been thinking about doing for quite a while. So I thought this was a good opportunity to start a video series documenting this process of building this project. Now, the first thing well, there are many things you want to decide, what platform to use, how you're going to go about this project. But really, at the heart of it all, it's just about measuring the voltage and measuring the current and keeping track of that over the time, because the product of the voltage and current gives you the power. Now, so we have a nominal voltage at the outlet of 240 volts. And I was thinking to myself, can I get away without actually having to measure the real-time voltage? Can I assume that it's 240 volts? Now, some of you might be wondering, why would I want to do something like that? Well, for one, if I can just assume the voltage as 240 volts and not measure it, my circuit would be a lot simpler. And there could be more isolation between the measuring circuit and the actual mains power. So there are some reasons, and I guess I'm just lazy. I want to keep it simple. I want to get it over with quick. So in order to really find out if we can assume that voltage, we'd have to measure the mains voltage over a period of time and just characterize that and see just how much variation that is. Now we could do that with something just like this. This is a Fluke 289, a really nice meter here, and it's got logging functions. So I could run this for, I guess, an hour, for a day, maybe 2 days, and just look at how the voltage changes over that period of time, how stable it is. But this runs on battery, and I didn't want to run this down. So what I thought I'd do is I would use this. I have a Tektronix DMM4050 6.5 digit precision multimeter. So this is what we're going to use. We're going to try to make this work. It's got a LAN built in, so it's network enabled, and it's got actually some really nice features. We'll take a quick look at this. I like to make this work. Okay, so we have the Tektronix DMM4050 here, the 6.5 digit precision multimeter. I got this probably about 6-7 years ago now, so it's not a new unit, but it's worked pretty well. And you turn it on like that, and you've got the whole setting here. So what we really want to do is we want to put in the AC mode, and I'm going to just hook this up to the mains in AC so we can just get some voltage here. Not really the best way to do this. It's a little bit dangerous, but things we do for. Okay, so we should get, so that's the outlet power level at this particular point of time. Now this unit has a whole bunch of neat features, right? First thing you want to do, of course, you want to set it into get your network connectivity. So you set in instrument setup, you go to port IF, you select LAN, you pick DHCP. Well, I've got it already set, and then it will assign, you get a IP address from the router. If you're doing this for the first time, after you set DHCP, you need to actually turn off the machine via the switch at the back, and then get it on again before this setting will actually register properly. So now we've got this going on. We've got in AC, we've got the voltage. Now it's also got some really nice logging functions. So under the analyze menu, there's something called trend plot. Of course, you could do histogram and other things, which we could use, but we have this trend plotter, so it will actually just plot a chart over time. Now the thing with this is that it will only do this for a fixed number of samples. So if you really want to log it for a long period of time, it might not be the best solution. So I thought, because this thing is network enabled, why don't we try and do that over the internet? Why don't we try and access this meter from the internet over the sorry, not the internet, over the network, and see what we can do with it, just for kicks. All right, so that's what we're going to do right now. Okay, we're going to do this from Ubuntu. So I'm going to open up a terminal right now, and I'm going to actually telnet the address that we saw just now, which is 192.168.1.62, and we get this login. Okay, so basically some sort of Linux or Unix kind of shell login, to which I don't have the user. Try something, maybe guess, and maybe try password. Okay, that didn't work. Okay, we didn't think that would work. In actual fact, what you really want to do is you want to actually use port 3490, which actually brings you up to this special interface which accepts SCPI commands. So for example, you could do something like this, IDN and question mark, and you could get well, I guess the ID for that machine. You could do other things as well. Now we could, for example, set to do more commands, you actually have to set the system, which is SYST, on remote. Okay, so that now you can see that on the machine itself, it's gone into a special remote mode. And then when it is in this mode, you can do other things like read. Yeah, there you get a reading there, right? So you read, and it takes quite a while to get that reading, about 3-4 seconds sometimes. Okay, so we'll talk about that later. But before we really get into this, what I'd like to do is I'm curious about this. You know, I mean, can we log into this? And if we could, what secrets does it hold? Okay, so what I'd like to do before we really jump into this project is to see if we can actually log into this. But how are we going to get a hold of the user and the password? Okay, so we're going to do a little bit exploring here. So a search of the internet didn't turn up a whole lot of useful information about how we might be able to get into that shell. You know, I mean, there are no passwords, no usernames, even actually no mention of this particular feature at all. I don't think anyone has ever tried this. Looked on EEV blog, no information there as well. But we did turn up this little bit of detail here. Now the DMM 4050 is actually a rebranded Fluke 8846A, and this here is the firmware for that machine. So I thought, why don't we download this and look at it? So that's what I did. I already pre-downloaded it, and the easiest way to, I guess, to get into the insights would be to install it. You could extract that, but it seems to contain some other stuff. So we're just going to install it on the machine right now and see what kind of files it contains that, you know, is used to update in the machine, the firmware in the machine. Right. So this is going to take I guess it's going to take a little bit of time. Not sure how long that would take. Let's see. Just going to install this. Okay, there we go. Okay, so the idea here is that we are hoping that we can actually maybe explore some of the files that are used to, you know, to update the firmware in the machine, and hopefully that might give us some clues. So we're going right here, the files installed in this directory here. We're looking for the actual firmware directory in 884x. This is it. Okay, so here we are going to find a list of files, and they are all, you know, I mean, they're all different functions and parts. You can see BusyBox there, so that's Linux. But the one we are really interested in at this point of time is that jffs2.bin file. Okay, that file probably you know, is used to, well, it's a special format for Flash, and we're going to have to actually look into this file, and we're going to have to mount it. So we'll move over to Ubuntu, and we'll try and see if we can you know, I'm going to put this file here, and then we're going to switch over to Ubuntu and try to mount that file as an image for a directory, right? Okay, so now we are over in Ubuntu, right? And we have that file, jffs2bin. We're going to have to find a way to mount this. And it's not your usual image, so it takes a couple more extra steps to actually get it mounted. And if successful, hopefully, we can find some useful information in it. Remember, this is actually for the Fluke 8846A. Okay, so We've already written it out, so now all we need to do is to mount the file and see what we have. Okay, there you go. That's the root directory, and what we are really interested in is actually in the etc directory. We want the password file. Actually, we want the shadow file. Let's go ahead and grab this hash, and I'm going to try and use hashcat to crack this password. This is old, probably UC Linux, so it's using DES encryption. So we're going to use hashcat and see if we can perhaps crack it. We're going to brute force it, so it will take quite a while. I've actually run this, and the output, the result was actually the password STRA TTS, so TTS5. So let's telnet 192.168.162, yep, and root, and the password capital STRA TTS5. Okay, well, that doesn't surprise me because, you know, first of all, this is for the Fluke 8846A, and you know, the engineers at Tektronix might have changed the password, but you know, it was worth a try. Okay, and it was an interesting thing. But we're going to do now, what we're going to do now is maybe more traditional. We're actually going to write a little bit of Python code to talk to the bench multimeter over the LAN and maybe extract the data. Okay, so what we're going to do, we're going to write a short Python script that talks to the thing. Simple script uses the IP address that we got earlier on, and then you know, it calls some functions that I wrote. Basically, you initialize a session over telnet using telnet lib, and then you well, this is where you actually do the communications, right? You send some initialization code, and then up here you have the routine that actually talks to it. These are the actual commands down here that get sent over the telnet, and then it reads back the function. So let's just run it and see what we get. There you go. Now this is high speed, but normally it takes about 3 seconds per reading, right? So it's actually quite slow, but a lot quicker in DC. Now after all that, I ran this for one whole day, we get these results. You can see that the range, the voltage range actually spans from about 200 and I guess 238 volts to 247 volts or so, and it's quite a big span. So you know, that alone tells you that it's probably not advisable to assume anything about the nominal voltage, because you know, you have a nominal voltage but the range is pretty big, and then over the day you can see how it goes up and down, these different spikes here and sudden dips, and that I don't know exactly why this happens, but I think we can safely say that the idea about not having to measure the actual voltage is probably not really good. So what we're going to do actually in the next video is we're going to actually begin looking at the system itself. We're going to have to measure the current, we're going to have to measure the voltage, and hopefully we'll get a working device, and maybe talk a little bit about what else we want in the system. So, well, this is what we have so far. I'll see you in the next video.